All right, let's dive in. Today, we're going to pull back the curtain on one of the most powerful ideas in all of programming. It's kind of like the secret ingredient that makes almost everything you use on a computer actually work. So, here's a bit of a riddle for you. You've got your alarm clock, which does the same thing every single morning. You've got a video game, which is constantly checking what you're doing. And you've got your social media feed, just loading post after post after post. I mean, they seem completely different, right? But they all share this one core secret ingredient. And there it is. The answer is loops. It's this super simple but absolutely brilliant concept of just telling a computer to do something over and over and over again. And that simple idea? It's the engine that drives so much of our digital world. Now, to really get why loops are such a game changer, we first need to see what life is like without them. And trust me, it is not pretty. Okay, so let's imagine we want a program to show us the 2 times table. Simple enough. We could write a line of code to figure out 1 times 2, and then another line to show it. Then a line for 2 times 2, and show that. Then 3 times 2. You're already seeing the pattern here, aren't you? It works, sure, but man, does it feel clumsy.
Yeah, the problem becomes obvious really fast. The code is just the same few instructions repeated again and again. Can you imagine trying to do this for the 100 times table? You'd be copying and pasting all day long. It's so inefficient, and it's a total nightmare if you ever need to change anything.
To see exactly what's happening here, step by step, we can use this fantastic tool that lets us kind of peek inside the computer's brain as it runs our code. And that tool is called a trace table. You can think of it like being a detective, just following the clues. It's basically a logbook where we keep track of every little variable and watch how it changes as the computer goes through the program, line by line. It's perfect for really understanding the flow of what's going on. Okay, let's trace our clunky code. First, we set up our variables. Number starts at 1, times table is 2, and we'll say answer starts at 0. Then, boom, line 7 hits. The computer calculates number times times table, that's 1 times 2, and the value of our answer variable gets updated to 2.
Right after that, line 8 displays our answer on the screen. Then, we jump to line 11, where we have to manually increase our number variable from 1 up to 2. We're getting it all set up for the next calculation.
And here's where that tedious pattern just smacks you in the face. Line 12 does the next calculation, 2 times 2, which updates answer to 4. And then line 13 shows it. We're doing the exact same thing again. There has to be a better way, right?
And of course there is. So now, let's meet the hero of our story, the elegant, smart solution to all of this mind-numbing repetition.
I mean, just look at this. The difference is night and day. On the left, you've got the old way, which is long and clunky. On the right, you've got the loop way. It's compact, it's efficient, it's so much easier to understand. This isn't just about writing less code, it's about writing smarter code. So, the official name for this is a count-controlled loop. But in a lot of programming languages, you'll just hear it called a for loop. And its job is super simple. Take a block of instructions and repeat it a specific number of times. That's it. No more copying and pasting. So let's break down what this code is actually saying. That for number in range 4 bit, it's just a simple way of telling the computer, hey, I want you to count from 0 up to 4, but don't include 4. And for each of those numbers, 0, 1, 2, and 3, just run all the code that's indented underneath. It's as simple as that.
Okay, so loops are amazing for multiplication tables, but they can do so much more. Let's look at a more dynamic example to see just how flexible these things really are.
What if we want to make a countdown? We can totally do that. That range function is incredibly powerful. By giving it 3 numbers, a start, a stop, and a step, we can control exactly how it counts. So here, we're telling it start at 3, stop when you get to 0, and count down by 1 each time.
So let's just walk through the logic here. First, we bring in a special library that lets the computer talk. Second, we set up our loop to count backward from 3 down to 1. Inside that loop, we turn the number into text so it can be spoken out loud, and then we tell it to pause for 1 second. Finally, only after the loop has finished its countdown, the program moves on and says, go!
So, we've seen how loops work, but let's take a second to really understand why they're one of the most important concepts you can learn in programming.
It really all comes down to these 3 superpowers. First, efficiency. You just write way less code. Second, scalability. You want to change your countdown from 3 seconds to 3,000 seconds? You just change one number. And finally, readability. Your code is just so much cleaner, and it's way easier for other people to understand what you were trying to do.
You know, this quote from our source material just hits the nail on the head. Without loops, if you want to make your program bigger, you're just stuck repeating more and more code. But with a loop, your code can be reduced greatly. It's the difference between building a wall one brick at a time versus using huge, prefabricated sections.
And you've got to remember, loops aren't just for counting numbers. You can tell a loop to go through every single item in a list. I mean, think about it. A program that reads your shopping list out loud, or one that plays every single song in your favorite playlist, or even one that sends a text message to every single contact in your phone. All of that is powered by loops.
So when you really zoom out from your computer checking for new emails, to a video game rendering what you see on screen, to banks processing transactions, this simple idea of repetition is a fundamental building block. It's the silent workhorse, automating billions, probably trillions, of tasks across the globe every single second.
So I'll leave you with this question. Now that you know the secret, the power of telling a computer to do something over and over, what parts of your own life, what repetitive, boring tasks could you imagine automating away with just a simple loop? The possibilities, as you can probably guess, are pretty much endless.